Okay, Assalamualaikum. So I'm Dr. Wana Syahidah. Okay, in this video, I will discuss the 2.2 confidence interval for the population mean. So the first parameter that we are going to estimate here. Okay. So the objective is to estimate the confidence interval for the population mean when population variance or standard deviation is known or unknown. Okay. And then estimate the sample size by using the concept of confidence interval for the population mean. So so the second objective here, you are given the estimation error, you are given the alpha, then what sample size, okay, should we use when we have this kind of information. So sample size here, it is a small n. Notation that we use is a small n. Okay, so how to construct the CI? Okay, we in general, okay, how do we construct the CI here, confidence interval here? Okay, actually we use the central limit theorem, the theorem of the central limit theorem, in order to come out with this confidence interval. Okay. Okay, I don't think that I need to discuss in detail here. We go to, okay, this one already discussed in the video for the 2.1. Okay. Okay, we go to the formula. So confidence interval for the population mean. Let me see. Okay. Okay, so actually this one we already discussed in the video of the 2.1 lah. Okay, but here you can see lah the figure, okay, illustration of the okay, the lower limit and also the upper limit here. Okay, so this is the distribution. Okay, so as I said in video 2.1, distribution here depends on what parameter that we estimate here. So the value of your distribution will be obtained from the statistical table. That's why when we discuss this chapter onward, okay, you need to have your own statistical table. Okay, so that when we said, okay, find the value of the Z alpha over 2, then where to refer in your statistical table. Okay, so you should have your own statistical table. Okay, we go to this one, the formula, confidence interval for the population mean. Okay, so how do we know that we are going to construct the confidence interval for the population mean? Okay, so first, sometime in your question, it will be mentioned that construct the confidence interval of the population mean, or maybe construct the confidence interval of the average, or maybe construct the confidence of the mean of something like that. Okay, it will be clearly mentioned in your question. Okay, or if it is not clearly mentioned in your question, how do we know that we need to calculate for the mu, or we need to estimate for the mu? It is based on the information given. Okay, based on the information given, then we know. Based on the information given, what we can calculate from that lah. Okay, what we can calculate from that. Okay, and also as I mentioned in the video 2.1, also depends on the variable itself, whether you have the qualitative, whether you have quantitative. Okay, if you have qualitative, like frequency of the something like that, then most of the time it will be proportional. If you have quantitative, then it will be either mu or sigma square. Okay, so it is back to the information lah, what we have in that question. Okay, so okay, so for the calculation here, okay, so we have two situations. Okay, in order, so we have, okay, in general, we have three formula how to calculate the confidence interval for the mu. Okay, so how do we choose this formula? The first situation that we need to determine, this one, the first one here, whether you have sigma is known or whether you have sigma is unknown. This is the first condition that you need to know. Okay, in order for us to choose which formula that we need to use. Okay, so sigma is known means that you do have the population variance in that question, or you have the population standard deviation. Okay, you have sigma square or sigma. Okay, so here kita akan we are going to so here is actually back to the chapter 1. Okay, how do we know the value given is a population value, and how do we know the value given is a sample value? So you have to go back to the chapter 1 when we discuss population, what is population, what is sample. Okay, so you have to know. Okay, in that question, you have the population value or the sample value, because we need to decide here which condition that we have, whether sigma is known or unknown. Okay, so unknown here means that you have S square or S in that question. There is no sigma in that question. It is S. Okay, so how do we know that value is a sigma is or S? It is not like, oh, I have variance, then it's a sigma. No, a sigma square, no. It is based on the situation in your question. Okay, the value that we have here, they are coming from the population or sample. You have to determine based on the question. Okay, I think when we go to the exercise, when you do the exercise, you will be well known with that situation. Okay, you will be well known. You will be aware. How to say, you will be well known with that situation, whether the value is given from population or from the sample. Okay. Okay, known means that you have sigma square or sigma in that question, then we use the first formula here. Okay, the first formula here, you have Z alpha over 2, you have the sigma. Okay, sigma here to show that it is for the known. Okay. Okay, so first, no need to memorize the formula. All the formula here, it is in your statistical table. Okay, page 5. Okay, confidence interval for the mu. Okay, so when you have class with your lecturer, virtual class, then you can ask the lecturer to show to you lah. Okay, where is the formula in that statistical table? But actually it is on page 5. Okay, you have all those three formula confidence interval for the mu. Okay. Okay, but the formula in a statistical table, it is not complete as what we have here. It is not mentioned which one for the sigma is known, which one for the unknown. Okay, you have to know by your own. Okay. Okay. If unknown, then we have another condition that you have to determine. It is the n. Whether your n greater than equal to the 30 and less than 30. Okay, greater than equal to the 30 means that you will have Z here. So the second formula here, okay, the formula with the S is a sample standard deviation with the Z. Okay, if you have n less than 30, then also we have S here to show that it is an unknown. Okay, we have sample standard deviation in that question. Okay, and but the distribution that we use is a T distribution. Okay, so T distribution, we do have probability value alpha over 2 and nu. Nu is a degree of freedom. So n minus 1, it is a degree of freedom. Okay. Okay, so how do we use this formula? We will discuss in detail when we go to the exercise after this. Okay. Okay. So we do have the example here. You can always read this example I'm going to discuss the exercise. Okay, so this is after we discuss the exercise, I believe that you can go back to this example and try by your own, okay, based on what we discussed for the exercise. Okay, so you can answer this question, example 2.2, based on example 2.1. Investigate the effect of the sample size, standard deviation, and confidence level values on confidence limit. So confidence limit here means that the width of confidence interval. Okay, what happened when we change the sample to the 100? What happened if we change the population standard deviation to 1 kg? Okay, what happened if we change the confidence level to the 95%? Okay, so this one you can refer to the video 2.1. I already discussed. Okay, I have discussed in the video 2.1. Okay. Okay, so this is example 2.3. Okay, determination of the sample size. So the second objective of this confidence interval is to determine the sample size by using concept of confidence interval for the population mean. Okay, so you have this formula. Okay, also in your statistical table. Okay, page let me see, page 8 in your statistical table. Okay, page 8. Okay, so we have two formula for the sample size. The first one is this one, and the second one, we use the concept of the proportion. Okay, for the proportion we do have notation P lah, so you can distinguish. Okay, if you have sigma here, then we use the concept of confidence interval for the mu. Okay, so the sigma here could be also the S. Okay, depends on what information that we have in that question, whether you have sigma or whether you have the S. Okay, then you just substitute in this formula. Okay, you find this value in your statistical table, then you can get the value of n. Okay, so n, it is a sample size. It should be discrete number or the whole number. So if you get the decimal point, the continuous value, we round up to the next whole number. Okay, so the final answer should be discrete number because of sample size. Okay, oh sorry. Okay, so this is the example for how to find the n. Are we back to this one, to this example after we discuss this exercise? After we discuss the exercise, okay, so this is the one-sided lower bound and upper bound. Also I will discuss in exercise, but in general, okay, we are using similar formula. This one, okay, we still need to know what condition that we have and then which formula that we need to use. What we modify only the alpha here. When it is a one-sided alpha, it is not alpha over 2, it is just alpha, so we just modify that. And then if a lower bound, then we use the -1, the a formula for the a. If it is a upper bound, then we use formula for the b. Okay, so similar formula, just a little bit modification. Okay, I will show in the exercise. Okay, so exercise 2.1, okay, I will discuss the number 1 here and also the number 3 here. Okay. Okay. Okay, number 1. So, okay. So first, what we do is extract the information. Before we go to the solution, before you do anything on the solution, the first thing that we need to do is information. Extract the significant information that will help us when we do the calculation. Okay, so the mass of the vitamin E in a capsule manufacturing Okay, manufactured by a certain drug company is normally distributed with standard deviation of 0.042. A random sample of 5 capsules was analyzed and the mean mass of the vitamin E was found to be 5.12 mg. So find a 95% confidence interval for the population mean mass of the vitamin E per capsule. Give an interpretation of the parameter estimate. Okay. It is very clear here. We need to find the confidence interval of the population mean mass. Okay, of the population mean. Okay, for the population mean. Okay, so clear, very clear. Okay. Okay, so first, let me use different color. What is the variable? Okay, so variable, how do we identify the variable? Variable is a data that been collected. What kind of data that being collected here? Okay, so you can identify based on the value that we calculate. What the value that we calculate is from what? That what is your variable. So if you can see here, mean mass of vitamin E. So we are calculate. So here the mean, we calculate mean here from the mass of vitamin E. So mass of the vitamin E is your variable. Or you can identify from the question here. Find the 95% confidence interval for the population mean mass of vitamin E. Okay, so we try to estimate population mean of what? That what is your variable, because that what we collect, the data that we collect. So that's your variable. So mass of vitamin E. Okay, so here you have the unit given, so mg. Okay, so what we have here, we start from above, the first sentence. Okay, the mass is normally distributed with standard deviation of 0.042 mg. So normally distributed, okay, we do have like this. So mass is a variable, x represent variable here. Okay, normally distributed with standard deviation 0.042. Okay, like this. Okay, 0.042. Okay, so the standard deviation here from this normally distributed, then it is a parameter. This is parameter. Okay, when we transform this sentence into mathematical writing, it is a normally distributed with, here is a mu actually, population mean, and standard deviation here, so it is a parameter. It is coming from this mathematical writing. Okay, when you have word normally distributed, it is parameter value. So automatically 0.042, that's your sigma. Okay, a random sample of 5, sample of 5, so that's your n equal to 5, was analyzed and the mean mass of the vitamin E was found to be 5.12. So 5.12 here was calculated from this 5. Okay, 5.12 was calculated from the sample of 5. So it is x bar because of mean. Okay, x bar 5.12. So the mean here was calculated from sample 5, then it is x bar. Okay, so what else that we have? So we have 95% confidence level, then alpha is 5%. Okay. Okay, so that's it, the information that we have. So After that, you can continue to the solution. Okay. After this, based on the information given, we try to solve this problem. So we need to know which formula that we need to use. Okay. So we go back to the formula. The first condition that we need, sigma is known or unknown. Okay. Pening sikit. Okay, saya pun pening. Okay. So we need to know sigma, the first condition, we need to know sigma is known or unknown. So based on the information, you do have the sigma. In your information here, we have sigma. So sigma is known. So we use the first formula. Okay. In this question, it is not mentioned whether it is a one-sided. So it is a what we call the basic confidence interval lah, with two-sided. Okay, so the normal confidence interval. Okay, so sigma is known. We use the first formula, which is x bar minus z alpha over 2 multiply with the sigma over square root n. Okay. Okay, that's your lower bound. So upper bound s bar plus z alpha over 2 sigma square root n. Okay, so we already know which formula that we need to use. Then fine. Okay, you have your sigma from this information. You have your s bar from this information. Okay, you have your n. So we have everything except the distribution value. So find the distribution value. Z alpha 5% divided by 2. So 0.05 divided by 2. Then you have 0.025. Okay. So where to find? Okay, it is in page. So we refer to the table 4 in your statistical table. Okay, page 36. Okay, so I'm using the letter statistical table. Okay, if you use the old one, so it might be page 35 or 37 like that lah. Okay, but table is similar. Okay, it is a table 4, percentage point of the normal distribution. Okay. Okay, if you have your own statistical table, you can refer now. You have column for the alpha, you have column for the z alpha. So find in your table, in a column of alpha, where is 0.025? So 0.025, it is alternate. The column is alternate alpha, z alpha, alpha, z alpha, alpha, z alpha until the end. Okay, so find in the column of alpha, where is 0.025, and then you can read that z alpha. So we have 0.025, the second column of alpha or the third column here, second row 0.025, the z alpha is a 1.96. I hope that you get. Okay, but I think lecturer, you can ask the lecturer during the virtual class. Okay. So we do have the z, the distribution here. Then substitute in your formula. So you have your what we call S bar sigma okay, solve this one first, and then 512 minus this one. Looks simple, but some students did a mistake there. Okay, should be 5. Okay, use a calculator wisely. No, it shouldn't be here. Okay, so you should get Okay, you should get for the lower. So how do we write the confidence interval? We start with the lower bound first. Okay, lower bound and upper bound. If you write upper bound first and the lower bound, 1 mark will be deduct. Okay, so lower bound first, because we read the smaller one first. Okay. Okay, so use for decimal places. Okay, I think lecturer already highlight from chapter 1. All the calculation must be at least in 4 decimal places. Okay, so here we do have the unit. So you have to state unit here, mg. Okay, so mean shoot with the unit lah. Okay, it is not dimensionless. Okay, and then so we already get our interval, then give an interpretation, so we have to interpret. Okay, are we right here? Okay, so we have 95% confidence level, so we are confident that you can just copy your question here, that the population mean mass of vitamin E lies between, okay, don't forget the unit 50832 mg and mg. Okay, so when we interpret this confidence interval, okay, it is important to note what parameter that you estimate. Okay, very important. Okay, without this parameter, then your interpretation is useless. There is no significance on your interpretation, because reader do not know what kind of parameter that you estimate. Okay, so you can repeat this exercise for the better understanding. Okay, I stop here. Next exercise on the next video. Thank you.